Section 5 for factoring polynomials. The first thing that we do in factoring is look for a greatest common factor. Sometimes that's the only part of the polynomial that can be factored. Once we've checked for that, then we can move on and use some of the other formulas or methods. So let's take a look at this first example. If you'll notice here, I've broken apart each term into its factors. You don't need to write this step down, it's just helpful in this explanation so you can see where everything is coming from. We look at the factors of each term and we look for the greatest common factor. So you'll notice that each term has a 5. Each term has at least one a, so we can factor out 1a, and each term has at least one b. So that means we could factor out a 5ab of each term. And this is the reverse distributive property. And it gives us an answer of 5ab times 2a squared b plus 3a minus b squared. Try this one. Let's take a look at example 2. Here, we can't find a greatest common factor, so we've got to try something else. In this particular case, we want to first group. We're going to make groups that we can factor something out of. Here we'll group the first two terms and the last two terms. In the first group, we can factor out an x squared, and in the second group, we can factor out a negative 2. That nicely leaves us with an x plus 5 in both terms. Now we can factor that greatest common factor out. And when we do that, we get a result of x plus 5 times x squared minus 2. Try this one. A way to factor a trinomial is with guess and check. This is best used when the a value, or the coefficient of x squared, is 1. We'll look at the constant, in this case, which is 15, and the center term, in this case, which is 8x. We're asking ourselves, what two numbers, or factors of the constant, can be added to give us that center term? So we could think about the 15 as having several factors. 1 and 15, negative 1 and negative 15, 5 and 3, and negative 5 and negative 3. All of those can be multiplied to equal positive 15. But only the positive 5 and the positive 3 can be added to equal 8. So those will become the constants in our factors. You can see here x plus 5 and x plus 3. To check our work, we would FOIL, and we should get the original trinomial. Another method for trinomials is what's called the British method, and it's best used when the coefficient in front of x squared is greater than 1. Here we'll take the first term and the constant, or the last term, and multiply. The 24x squared is the result of the constant times the first term. We're going to ask ourselves what factors of 24 will add to give us 11. And in this particular case, that question leads to the splitting of that center term. It's as though you're going backwards through the FOIL process. Remember, when you're FOILing, the step before you get your final answer, you have to combine like terms, those two center like terms. That's what we're trying to find, are those two terms that were collected. So here you can note that 8 and 3 were the factors of 24 that, when added, gave us 11. So we split that 11x into 8x plus 3x, and then we group just like we did in a previous example. When we look at the first group, we can factor out a 2x, and the second group, we can factor out a 3. That nicely leaves us an x plus 2 in both terms, and again, we would factor that out, and the result is x plus 4 times 2x plus 3. So here's an example that you can try. Notice with this example that the second to the last step where we factor out of each group, we have to factor out a 1 in that second term. So that allows us in the answer to have a y plus 1. You'll also need to know some of the formulas that we saw at the beginning. One of those is the difference of two squares. Here you can see we've got x squared minus 16, square number 1 minus square number 2. Step 1, we'll find the square root of each of those terms, and then we'll factor into two binomials. Now here, if I take the square root of x squared, we'll get x, and the square root of 16 will get 4. But because we're subtracting 16, we have to have one positive 4 and one negative 4. So the result is x plus 4 times x minus 4. In general, root number 1 plus root number 2 times root number 1 minus root number 2. Here you'll also see listed again the formulas or equations for difference of two cubes and the sum of two cubes. Make sure that you know that that we can factor the sum of two cubes, but we cannot factor the sum of two squares. So let's look at an example. Here we want to first factor out the greatest common factor, which is 5m, and then we have in parentheses p squared minus 9, which is in fact the difference of two squares. Another example. Here we need to make sure that we can identify cubes. This is xy cubed plus 2 cubed, or the sum of two cubes. So we would follow the formula. Here we can notice that this polynomial could be considered the difference of two squares or the difference of two cubes. So we need to make sure that we do the difference of two squares first always. So let's do that. We'll square root each term, making sure to add and subtract. And now in our solution we've got one sum of two cubes and one difference of two cubes. So we'll follow those formulas. Another way we can use factoring is with quotients. So we've done dividing of polynomials in this chapter already. Here's another method. We can factor both polynomials that are on the top and the bottom, or in the numerator and in the denominator, and nicely we end up with an a plus 2 in both places. Those will eliminate or become 1, and so we're left with the a minus 3 over a plus 5. Making sure to include in our answer the restriction that a cannot be negative 5 and it cannot be negative 2. Those two numbers would result in a 0 in the denominator, and we can't divide by 0. So here's one for you to try.